Okay, let's take a look at sample exam 2, Chem 11, number 15. This question has three different parts to it. The first part tells us to use the ideal gas equation to calculate the pressure exerted by a gas that's given in the question. So there's a bunch of information here in the question with volume, number of moles, and temperature. So that's a fairly straightforward question to solve. So just to use the ideal gas equation, which is PV equals nRT, or if you rearrange it for pressure, it will give you that. And you just plug in the numbers that they give you. So 1 mole, and then the gas constant, temperature at 0 Kelvin, 0 Celsius, which is 273 Kelvin, and then 2 liters. And so that gives us 11.21 atmosphere. Now the second question asks you to use the van der Waals, or the real gas equation, to calculate the pressure. So we use the same exact numbers, except that we assume now this condition is such that the gas doesn't behave ideally. So we have to use the real gas equation, or the van der Waals equation is P, in this case for the real gas, is going to equal to nRT over, instead of just V, it's V minus NB, a component that takes into account the volume of the particles. And then the other thing we subtract the pressure with is A times N over V squared, which is a measure of the strength of intermolecular interaction that exists in the real gas that doesn't exist in the ideal condition. Okay, and once you remember that equation, it's a matter of plugging in the numbers that is given to you. Notice the A and the B constants that is part of this equation is given right here in the question. So we basically just need to plug in those numbers. And so let me do that. So 1 mole, I'm going to take out the units here just to be able to fit all the numbers in my writing. So 1 times 0.0 times 273 divided by 2 minus 1 times 0.0562, that's the B value. So that's one component minus then A, which is 6.49 times 1 over 2 squared that. Okay, and so if I plug in the numbers in the calculator, I'm going to get 9.91 atmosphere for that number. So if I assume it's a real condition, then the pressure would be quite different compared to the ideal condition. And so what they're asking you to do in part C is to say, what's the difference in the values of the pressure, which is called delta P, if you were to assume ideal versus the real condition. So you just subtract those two numbers. So your delta P is going to be your pressure ideal minus your real pressure, and that gives you 1.3 atmosphere. So you don't want to assume ideal gas condition for this specific combination of values for chlorine, because that would give you a pretty big error in terms of actual pressure that you get. Okay, and the question that follows from here is, without doing any further calculation, do you think the value of delta P would increase or decrease if the volume of the container is increased from 2 liters to 10 liters? While all the other parameters are kept constant. Okay. Now, so what you have to think about is, what's the effect of increasing volume? So remember that the reason a gas deviates from ideal gas behavior is because in the ideal case, we assume that the gas particle has no volume. And the reason we can make that assumption is because if we look at the container relative to the size of the gas particle, considering the size of the container is this big, you can pretty much say that that gas particle doesn't take up a whole lot of volume. Now, if your container has this size instead, and then you have the same size of gas particle, now you have to assume that your gas particle has a significant volume relative to the size of the container. So then in the big container, your gas would behave ideally, and in the small container, your gas would behave non-ideally, or we call it a real gas. In the question, what we're being asked is an increase in volume from 2 to 10 liter. So if there's an increase in volume, that means we're going from the real condition more towards the ideal condition. So in this case, we would expect the gas to behave more ideally as we're going from 2 liters to 10 liters.